Good morning, good afternoon, good evening, whatever the case may be. I won't make you go through the entire music, although it is awesome for part two of the awesomeness, the fundamental theorem of calculus. Don't you love the Newton and the Leibniz? Boom, boom, boom. Okay, I'll stop. Because we just have one example with two parts to do to finish this up, and I know you want to get to integrating yourself. Use the fundamental theorem of calculus to find the area between the x-axis and y equals x squared from x equals 0 to x equals 1. So let us do that. So here's what they're asking us to do. Come on now. Come on. All right, computer's being slow. So for part A, and why isn't this writing? Okay. All right, computer's back up to speed. Don't know why it's acting slow. Sorry. Okay, part A, they are saying find the integral from 0 to 1 of x squared dx. Okay, now we did this. We already know the answer is 1/3, but just a quick little sketch. Okay, that is a parabola that looks like this, right? And so here's 1 and here's 0. So we're looking for, let's see. Let me move that. You can't even see that, but I can see it on my screen. Okay, so I'll do like a blue line right here, straight down. And again, we are looking for this area here under the curve, all this good stuff. Okay, all right. So what we found from the fundamental theorem of calculus, the integral is equal to the antiderivative. Capital F is the antiderivative. So this will be equal to the antiderivative of x squared is x, the 2 plus the 1, so x to the 2 plus 1 is x cubed over 3. Yes? X cubed over 3. Now, if I take the derivative of x cubed over 3, or 1/3 x cubed, I get x squared. That's how I know for sure it's the antiderivative. And I evaluate that. This is the symbol that a lot of people use to evaluate that for the given bounds from 0, my A, to 1, my B. Okay? So this is my antiderivative. This is my capital F. So what I do here is I take my antiderivative of b, the 1, so I replace x with 1 cubed over 3, minus 0 cubed, my a, minus f of a, over 3. And so that would be 1 cubed is 1, so that's 1/3 minus 0, which is indeed equal to 1/3, which we discovered before using Riemann sums and limits. Okay? So that is our answer. Very nice. For B, they want us to find the area under the curve of root x from 1 to 9. If you don't mind, I'm just going to go ahead and write that as x to the 1/2 power dx. Okay? And recall, all right, Hannah, we'll take care of you. We'll dismiss. Okay, sorry about that. Recall that the graph, just so we know what it looks like, of the square root of x looks something like that. Okay, so from 1 to 9 is going to be this area right here. All of this. Boom, 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 boom. So that's going to equal, the antiderivative is going to be x to the, using our power rule, 1/2 plus 1 over 1/2 plus 1, evaluated from 1 to 9, which equals x to the 3/2 over 3/2, which evaluated from 1 to 9, which equals 2/3, okay, the square root of x cubed, evaluated from 1 to 9. And I'm going to go over here because of this mess here. So that equals 2/3 times the square root of 9 cubed minus, just using the fundamental theorem of calculus, antiderivative of b minus antiderivative of a, minus 2/3 times the square root of 1 cubed. And without doing all that arithmetic, I'm going to tell you that that is equal to 17 1/3 units squared. Okay? Now, good news, you can do this on your calculator here. Let me just add a page. I need a calculator. We're going to go to menu. Here, let me make this bigger. 200%. Okay, we're going to go to menu, calculus, numerical integral, and all we have to do is put everything in. The first one was from 0 to 1 of x squared dx. Hit enter, and we get 0.33333, which we know is 1/3, and you know how to use your calculator to change it to 1/3. The other one, menu, calculus, I could have gone up and copied that, I suppose. Numerical integral. So that was from 1 to 9, so we're going to expect this to be 17.3333 of the square root of x dx, 17 1/3. So that's how you can use your calculator to do it. Hope you enjoyed it. What a glorious, glorious day it has been. We shall see you in class. Can't wait.